Alright, welcome to Intro to C Programming. Today we're going to write a program utilizing if statements, a conditional statement, and here's the program we're going to write. We're going to read a character from the user, read a character and a value from the user. And the character is going to determine whether we want to convert the value that we read from the user to hexadecimal, octal, or binary. So, to start off, I'm going to be using Microsoft's Visual Studio to write this program. So I'll open up Visual Studio. You should get to something that looks like this. Click on New Project. Make sure you select the Win32 console application. Give it a name. And name mine Lecture 4. Say OK. And then click Application Settings. Make sure you have Console Application checked. Make sure you have Empty Project checked. And then say Finish. That should give us the Solution Explorer over here on the left-hand side where we can add a new file to it. So underneath the source files, right-click, say Add New Item. And then we're going to select the C++ file, .cpp, and then give it a name. Let's see, I will name this conversion.cpp, and then say add. You can name it whatever you want. If you don't want to name the same thing that I did, there's nothing wrong with that. You can name it anything that you want. Okay, here we've got our window now where we're able to start writing code. The first thing that we want to do, if we want to do any kind of input or output in C, we are going to have to include the standard io.h header file. The entry point to any of our C programs is going to be the main function. The syntax of the main function we're using here is it doesn't return anything, so I make the return type void. I didn't say the name main, that's the name of the function, followed by the open parenthesis and the closed parenthesis because I'm not passing any parameters into the main function. Open your curly brace, go down a couple lines, and close your curly brace. Now, we need to be able to read two things from the user in this program. The first thing we wanted to read was a character, and the second was going to be a value. So let's go ahead and create a character. This is going to be my conversion type, and then I also want to read a number that I want to convert. I'm going to make it an integer, makes it a little easier for converting. There are ways to convert floating point numbers to these other number types, but I'm just going to make an int, so it makes it a little bit easier for us to convert between a decimal number and a hexadecimal, an octal, and a binary number. So I'm going to just create a variable. I'll call it number. Okay, first thing I want to prompt the user and say, hey, what do you want to do? So prompt them and say convert to, I'm going to say hexadecimal, and then I'll put an H in parentheses. Octal, put an O in parentheses. Or binary with a B in parentheses. And so this is just my way of trying to tell the user, hey, you know what, if you want to convert to hexadecimal, type an H. If you want to convert to octal, type an O. If you want to convert to binary, type a B. Pretty straightforward, pretty clear. I think people might be able to understand that. Now I want to read in whatever the user typed. What I want to read it into, though, I use the scanf function. I want to read it into a character. To read into a character, I use %C. If I want to read it into an integer, it'd be %D. A floating point number would be %F. There's a couple other characters that we can use there. But if I want to read into a character, it's going to be a %C. Now I have to put the ampersand in front of it. This is saying that I want to read it into the variable named conversion type. And that's going to read in a character into that variable type. Now, after I've read that character in, what do I want to do? Well, I want to find out whether they typed in hexadecimal, octal, or binary. But maybe before I do that, my next step is going to be to prompt the user and say, hey, what number do you want me to convert? So let's do another printf and say, what number would you like to convert? And then we're going to read that in. Now, if I'm going to read this into an integer, it's going to be with the %D. That's right. And make sure you don't forget that ampersand in front of the name of the variable into which you would like to read that value. So I have my %D followed by ampersand number. That should read it into that. Now, I just want to check and make sure this is going to work, so I'm going to print out my number and my character. So conversion type and number. Let's go ahead and do that. Build your program. Let's make sure that this runs before we keep getting bigger and bigger and our program keeps getting longer and longer. Down here at the bottom you should see, hopefully, we've written some good code. There we go. Build succeeded. So let's go ahead and run it. There's my program. Convert to hexadecimal, octal, or binary. Let's say hexadecimal. What number do I want to convert? I want to convert the number 14. And then you see on the next line I have H, followed by space, followed by 14, followed by a new line. That's all that I wanted so far. All my program is doing is just saying convert to hexadecimal, octal, or binary. I read it in. What number would you like to convert? I read it in, and then I just printed out the two things that the user typed in. So I printed out H and I printed out 14. If your program is not working like that, then go ahead and pause this, check over what I've written right here on the screen, and make sure that you get your program working properly. Okay, I'm going to go ahead and take out that line there. We know that I've read in those two values into those variables. The next thing I want to do now is to convert it. I have to know whether they want to convert it to hexadecimal, to binary, or to octal. So I'm going to say if the value that the user typed is equal to the character H. Now notice that if I want to compare it to a character, I'm going to use the equality operator. Remember, there's two equal signs there. It's not just one equal sign. If I just put one equal sign, that's the assignment operator, and that's going to assign the character H to that variable. That's not what I want to do. What I want to do is check to see if the variable conversion type has, the value of that variable conversion type is equal to the character H. So I use the two equal signs for that. That's the comparison operator, the equality comparison operator. I put the single quotes around this character H. The reason the single quotes is because I'm comparing a character. I'm not comparing a string, okay? The double quotes will not work. This designates a string, not a character. So I need to put the single quotes around that character H. That's going to denote that this is a character, and I'm comparing a character to a character. And I want to see if the value is H. Now, we're going to put something in the body of that if statement. But before we do that, I'm going to go ahead and let's check our other types here. If the conversion type is equal to the character O, that means that this is an octal. If it is equal to the character B, that means that I want to convert to binary. And now I'm going to have one other else here. And what is that else going to represent? That's going to represent, well, if you didn't give me an H, an O, or a B, then I don't know exactly what you want me to do. So I'm just going to put a little error message in here and say, you didn't enter H, O, or B. Just so that the user knows, hey, you know what, my program's not doing anything, but it's because you didn't give me the right character. I told you H for hexadecimal, O for octal, B for binary. You didn't give me one of those, so I don't know what to do. So that's going to be inside of my else statement. All we have to do to finish this program now is fill in the body of each one of those if or else if statements. We have easy ways to do some of these. Because we already have some special control characters, if we want to print out a number that we have as hexadecimal, we have a %x, and that'll print it out in the hexadecimal format. For an octal format, any guesses? That's right, %O, so we can print it out as octal. We don't have one to print out in binary. We're going to have to do a little bit of math for that. If you went over one of our previous programs, though, then you saw how we convert from decimal to binary. So, the easy ones, though, if we want to print out a value as hexadecimal, we're just going to put a %x in there. I'm going to put a new line character after that, just so it's easier for us to understand. And then print out the type the name of the variable that you would like to print out. So it's just a %x followed by a new line, and then the name of the variable. Now it's going to print it out in hexadecimal for us. So I'm going to add one more thing here. I'm going to say the base 16 of number equals x. And then I'm just going to put number in there twice. So this first %d is going to represent that one there, which is number, and this %x represents that variable there, which is also number. And now I'm going to do something very similar to that for the octal. The base 8 of my number is equal to, and now it's going to be a %O. And that will give me the octal representation of the number. The last one, the binary one. Now again, we haven't learned loops yet, so we're only going to be able to do it up to a certain number of binary digits, a certain number of bits. So in this case, I'm going to assume the number that we are going to convert to binary is going to be no more than 4 bits long. That'll give me any number between 0 and 15 inclusively. But if we go above that, we are not going to get the right answer. Once we learn how to do loops, then we will be able to figure this out, and we'll be able to do it for absolutely any number at all based on the limitations of the size of the numeric variables, of course. But we would be able to do it for any large number that you would like to. So the way that we do this, I'm going to need a couple more variables, so I'm going to come back up here to the top. Next to number, I'm going to do quotient, remainder 1, remainder 2, remainder 3, and remainder 4. We're going to need the 4 different remainders if we want to be able to print out a number between 0 and 15, because that can take up to 4 bits to do. Okay, we're going to start off by taking number and modding it by 2. And then we're going to say that our quotient is number divided by 2. And now our second remainder is going to be our quotient modded by 2. And we are going to reassign our quotient there. I'm going to show you a little shortcut, something else you could type instead of quotient equals quotient divided by 2. What you could type here instead is a shortcut would be quotient divide equal 2. And that does the exact same thing. It's just a little shortcut. The reason that we have that is because programmers are inherently lazy. If we can type fewer characters, that means that we can type more characters in a shorter amount of time. So what we're able to do here then is make it quotient divide equal 2. This is exactly the same thing. It's just a shortcut for doing it. Instead of saying quotient equals quotient divided by 2, we can say quotient divide equal 2. And it means the exact same thing. Nothing different there at all. Let's get remainder 3 as quotient mod 2. And then we'll get our next quotient. I'm going to use our new little trick that we just learned. And let's get our remainder 4. And we don't need to do the next one because we know that we're limiting ourselves to only having 4 bits. Otherwise, we'd have to do the quotient again and make sure that the value of the quotient was 0. And that's when we know that we finally have reached the end of our conversion. If you don't remember how we convert from decimal to binary, what we do is we just take the mod of, we mod the number by 2, and we take the remainder of that, and then we start dividing it by 2, just like we've done here, until we get down to a quotient that equals 0. Once we get down to a quotient that is equal to 0, then we just start copying from the bottom up of our remainder. So when we print this out, we're going to print remainder 4, 3, 2, 1. All of these numbers, since they're remainders when we're modding it by 2, are all either going to be 0 or 1. It is not going to be anything bigger or smaller than that, because that is the definition of the modulus, is that it's going to divide it by 2, and then it's going to return to me the remainder. The remainder is always going to be either 0 or 1. It can never be 2 or greater, because that means that we could have divided it by 2 at least one more time. Okay, print out the answer now. The base 2 of my number equals, and now I'm just going to print out 4 bits, followed by a new line, and number was what I was trying to figure out, and then I'm going to print remainder 4, remainder 3, remainder 2, remainder 1, done. Save it, run your program, let's see if our program converts. Build it. My build succeeded, and I'm going to start my program running it here. Okay, here's my program I want to convert. Let's start off converting to hexadecimal. I can choose any number to convert to hexadecimal or octal. I don't have to limit it to a number which is between 0 and 15, because this will work for any number at all. So I'm going to choose a number, let's say 32. 32 in base, the base 16 of the number 32 is 20. It's 20, and that's because the second digit represents the 16's place. So I put 2 there, which is going to be 16 times 2, which is 32. And that gives me that answer there. All right, let's run it again. Let's try an octal number here. So I'm going to do an octal number. What number do I want to convert? Let's see. How about 24? And you see 24 is 30. That's because the second digit is the 8's place. So 8 plus 8 plus 8, or 8 times 3 is going to give me 24, and I don't have any in the 1's place. So that worked also. Let's try our next one, which is the binary. Again, it's only going to work between 0 and 15, so let's try 13. Base 2 of 13 is 1101. That would be 1 plus 4 plus 8. 8, 4, 1, 2, 13. There we go. So that one worked out also. So all 3 of those worked. We just need to check one more condition. And let's try if I enter something which is not H, O, or B. What's going to happen? I'm going to enter J. What number do I want to convert? The number 34, and it's going to say, you didn't enter H, O, or B. So everything seems to work there. See if I can get the whole program on the screen for you there. There it is. There's our entire program, and this will convert a base 10 number to hexadecimal, octal, or binary. The hexadecimal octal don't have any limitations as to how big the number can be, other than the limitation of the size of a variable. Binary, on the other hand, though, since we are only using 4 bits in our conversion, it will only convert a number which is between 0 and 15 inclusively. The purpose of this program was for you to see how the if-else-ifs work. So you see I have my if statement right here, open the parenthesis, conversion type equal H. The reason I use the double equal sign, this is the equality comparison operator. I have to use that over the assignment operator, which would just be a single equal sign, because I'm not assigning the value H to this variable. Instead, I'm comparing the value of this variable to this character H. I have the single quotes around H because this is a character. If I wanted to compare strings, I would have the double quotation marks. However, we don't compare strings with the equal sign. I'll show you in the future when we get to strings how we would compare those. But characters are the single quotation marks. After my if, I have my else statement here. Inside my else, I have another if statement. So here's my if statement, conversion type is equal to O. Here's another else with an if statement following it. And then at the bottom down here, you see my last else statement. So it's only going to get into one of those four statements. It will never get into more than one of those. That's the reason that we use the else portion of that, so that we will only get into one of the bodies of the if or else if statements through any execution of our program. We will never execute more than one of those, the body of any of those if statements in our program. Alright, so now you've seen a program using if statements. We've converted all of these numbers again. We've read some input from the user, and we printed out an error message down at the bottom. Alright, so that's it for this program. I'll talk with you all soon.